Hello dear students. So here in this video lecture, I again Chetan Patil, your physics mentor, welcome you from Microvision Academy, Burhanpur. So here we are going to start again graphical representation, and using graphical representation we will derive the equations of motion. So what are the equations of motions? So it is said that mathematics is the queen of science. Why mathematics is said to be queen of science? Because mathematics is a very logical subject, analytical subject. Every step comes with the logic. Why there is a next step? And in the science, there is very much important how we logically derive particular statements. So equations represents a very large amount of information very precisely in a logical manner. So in the same way, equations of motions represents large amount of information regarding motion in a very small statement. So these are the equations of motions. So for equations of motions are made by this 5 parameters which you already know. These 5 parameters are initial velocity, final velocity, distance or displacement, acceleration and time. So equations of motions are the relation equations of motions. This gives the relation between these 5 quantities. How we are going to derive it? Let us see now. So here it is a velocity time graph I have drawn. So in the velocity time graph there is an inclined straight line to the x-axis by making a particular non-zero value initially. So initially non-zero value, this is a velocity, y-axis is representing the velocity. So here this particular value represents the initial velocity. Initial velocity is represented by u, letter u. So this is the time, total time covered, let us assume it is a small t in this journey. So here up to time t, here this is the origin. At origin the velocity when time was 0, the velocity was u, that is the initial velocity, and when the time becomes t, the velocity we assume it as a final velocity. Final velocity is represented by v. So let us give some name to these points. So let us consider this u point as capital A and this is B. So along AB our whole journey is there. Let us draw one perpendicular to the y-axis which intersect, and let us assume it point as C. Again from point B one perpendicular is there, let us assume that point as D, and from point A to BD there is, we draw another one perpendicular, we call this point as E. So here what these segments represent, we will write it again. Here the OA segment represent the initial velocity. It is denoted by U. OA is equivalent to AD here. Then OC, which is equivalent to BD, is giving the final velocity. U is initial velocity and this value, this particular value on the y-axis is the final velocity. It is denoted by V. Then comes the time. OT, which is also equivalent to AE, is giving time T. This is time. Now we will go toward the first equation of motion. First equation of motion. These equations of motions are also called as a kinematical equation of motion. So here we start with the definition of acceleration. So already we know that acceleration is the change in velocity with respect to time. So here our velocity changes from initial value to final value in time t. So here, but we are going to take the help of graph. So graphically, how we prove what exactly the acceleration is, or how we derive the first equation of motion. So here we have to consider the slope of this line. Now what is meant by slope? The slope is the inclination. For example, if there is a one platform which is having uneven heights, if we pour water on it at higher level, that water get rolled down to the lower level. So that is inclined one. Because of that inclination, the water flows or any fluid flows from high level to low level. That is called as inclination. So this inclination, if I drop water here, the water droplets will go like this. So this particular form, this is called as an inclination. So here inclination with respect to x-axis is there. This particular angle is being made with the parallel direction of x-axis. So that is called as inclination. This inclination geometrically derived by considering the 2 points on that line, any 2 points on that line. The slope, for example, if we consider this point and this point, point A and point B. If I want to calculate the slope of line AB, then the slope is defined as change in the y coordinates. Suppose this point is having the coordinates x1, y1 and this point is having coordinates x2, y2. Then slope will be calculated as change in y coordinates upon change in x coordinates. Change in y coordinates upon change in x coordinates. So here, if we take the values of these coordinates, and these values will be, here value of x0, x1 will be 0, because here x coordinate will be 0, because this point lies on the y axis, and value of y1 is u. This is u, which is the value of y1. And here for this, value of x1 is this time t, x2. And value of y2 is value of this segment, which is y2, which is equal to bd, which is nothing but v. So now substituting this value, and in velocity time graph, the slope represents the acceleration. So here we can say that both are equivalent for this velocity time graph. So here acceleration is equal to the slope. This acceleration is equal to the slope, and slope is nothing but y2 minus y1 upon x2 minus x1. If you want to derive these values, this x2 minus y2 minus y1, y2 is v here, and y1 is equal to u, and x2 minus x1, x2 is our time t minus initial time x1 is 0. So here acceleration, which is represented by small letter a, is coming like this: a is equal to v minus u upon t. So this is actually the definition of acceleration, change in velocity upon time. So we rearrange these terms, multiplying t on this side, we get a into t is equal to v minus u, and again transferring this u on that side, so we get u plus at is equal to v, or this is none other than the first equation of motion, v is equal to u plus at. This is our first equation of motion. V is equal to u plus at. V is the final velocity, u is the initial velocity, a is the acceleration, t is the time. So if you know any three parameters, we can calculate the fourth. Here 4 parameters are involved. So this is one of the important equation of motion which can be derived with the help of velocity time graph by considering its slope. There may be the different methods to calculate the slope. We can calculate the slope as it is given into the textbook. If you go into the textbook, it is slope is calibrated like this. Slope value will be the change in the y coordinates, and these y coordinates will represent the value of BD. So this BD minus ED, we already know this U is ED and BD is that final velocity. So BD minus ED, this value slope will be BD minus ED upon time will be the OD. So BD is B, ED is U and OD is T. In the same manner you will get the value of acceleration, which is equal to V minus U upon T. So this was the first equation of motion. Once again you understand it thoroughly and solve it on your own in your notebook. Now we will move further towards next equation. Second equation of motion. With the help of same graph, we have to use the same velocity time graph to derive all three equations. So here, now we are going to consider the area under the line AB for second equation of motion. Now, here, slope is generally the ratio of these two quantities, y coordinates upon x coordinate. Y was representing velocity and x representing time. So velocity upon time of course gives the acceleration. That's why slope is termed in terms of calibrated in terms of acceleration. Now if we consider the area under the line, if we want to calibrate this area under the line, this whole area, suppose if I divide this area in two geometrical figures. One is this rectangle OAED and one is the triangle AEB. So what does this area represent? So this area, how we calculate the area? We calculate the area by multiplying its sides. So for example, for this rectangle, we will multiply its length into the breadth. Length and breadth they are representing the quantities velocity and time. So when we multiply velocity with time, we will get the displacement as per the definition of displacement. We have already seen that velocity is equal to displacement upon time. So if we multiply by time here, so velocity into time, we will get the displacement. Here displacement is represented by letter S, small s. Don't confuse this small letter s with the speed. Speed is not represented by small letter s. For representing speed also the letter V is used. So remember this point. So here displacement is the product of velocity into time. So when we calibrate the area, we have to multiply that x-axis and y-axis quantity. That is, we have to multiply velocity and time. So that's why area under the line in velocity time graph will represent the displacement. And second equation of motion is none other than the equation for the displacement on right hand side. So second equation of motion, already I write that expression. The displacement here is equal to ut plus 1 half a t square. Displacement is equal to, this displacement here is equal to ut plus 1 half a t square. It seems to be some quite complicated initially, but if you understand the derivation, you will find it very easy one. So let us derive this equation now. So we will start from the area. Area under the line is representing the displacement. So how to calculate this area now? So this area under the line is the displacement. I will represent it with the help of letter small s. So this S is the area under the line, and I will divide this area in two parts. This is area of rectangle OAED plus area of triangle AEB. Area of rectangle OAED and area of triangle AEB. This is point A. So area of rectangle, you already know, length into the breadth. So here we consider length as OD and breadth as OA. So I write it as OA into OD plus area of rectangle, area of triangle AEB will be 1/2, yes, height into the base. So here already perpendicular is there. We assume it AE as height, or either you can assume BE as height and AE as base. So 1/2 into, we regard height as a BE into base as AE. We already know what this stand for. AE stand for T, OD stand for T, again OC is final velocity, OA is U. Now substituting these parameters, OA is nothing but U, OD is nothing but T plus 1/2. Now what is BE? So we have to derive this value BE. Here BE is equivalent to BD minus ED. But what is BD? BD is V and ED is U. So B is V minus U. So substituting this value in our expression for area for rectangle, B as V minus U. Now what is AE? AE is equivalent to OD, which is nothing but time. So here we substitute AE as T. We have now up to the final step. We got expression up to this values. S is equal to UT. Here S is equal to UT plus half is also there, but this parameter is missing. Now we will introduce this parameter. Now we already know the definition of acceleration. It is nothing but V minus U upon T. Now rearranging the terms, our first equation of motion, we know that V minus U is equal to AT. Now substituting this value for V minus U in this expression, we get the value as UT plus 1/2. Replacing V minus U as AT into T, we get the final expression UT plus 1/2 AT square. So this is our third equation of motion. S is equal to UT plus half AT square. It is quite simple one. I again briefly review that. What we did first, we consider the area under the line, which is representing the displacement in velocity time graph. I categorize this area under the line in two parts. One is rectangle, another is triangle. So displacement is represented as sum of area of rectangle and triangle. Then substituting the values for area of rectangle as U into T and area for rectangle as 1/2 U minus U, V minus U into T. And this V minus U is replaced as AT, and we get the final expression as S is equal to UT plus half AT square. So got it? So it is a quite simple one. Once again go through that derivations. Once you understand, write it that in your notebook on your own, then you will completely understand it. So now moving toward the third equation of motion. It is also quite simple. And third equation we will go using these two equations. Now in the third equation, our way to derive that equation will be the same like second equation of motion. Again, in third equation of motion, we are going to consider area under the line. Now, but that area we are not going to cover as a parts but as a whole. If you look this diagram, the whole area which is shaded here, the area or this figure AODP, this forms a trapezium. So what is trapezium? Trapezium is a kind of quadrilateral in which the two sides are parallel. So here the sides, this is also a quadrilateral OABD or AODP. In this OA and BD, these two sides are parallel to each other. Therefore, we can say that this figure OABD is a trapezium. And what is the area of trapezium? So we are going to consider here. So we already know that area under the line is the displacement, or that displacement is the area. So here the area we are going to consider the area of trapezium OABD. And what is the area? Check out your geometry books and quickly tell me. Okay. This displacement area, I will tell the formula for that. The area of trapezium is equals to 1/2 into the sum of parallel sides into height. Height is the distance between those parallel sides. Height is the distance between the two parallel sides. So here we will put the values of these sides. 1/2 sum of parallel sides. Parallel sides are OA and BD. And height will be either AE or OD. That is the distance between the parallel side. So I take it as a OD. So now substituting the values, 1/2 OA is U plus value of BD. Already we know that value of BD is B into OD. OD value is T. Now here 1/2 U plus V and T. Again we are going to take the help of first equation of motion. In second equation of motion, we replace this V minus U as AT. Now we are going to replace this value of T in this equation as T is equal to, from first equation, V minus U upon A. Substituting this value in this equation, V plus U into V minus U upon A. You got it? We have the replacement here. Previously in previous equation we replaced the value V minus U. Now here we are replacing the value of T as V minus U upon A. Now you already, there will again take the help of mathematics. Here one pattern is there. This is V plus U, U plus V and V minus U. I can write it as also V plus U. Now there is a pattern V plus U and V minus U. Quite resemblance with A plus B into A minus B. Yes, that formula is A square minus B square. A square minus B square is equal to A plus B in first bracket into A minus B in second bracket. Using this formula, I can write this as B square minus U square upon A, as A square minus B square is equal to A plus B into A minus B. So rearranging the terms, I will take this 2A on this side, so it becomes 2AS is equal to V square minus U square, and this is nothing but our third equation of motion. By rearranging the terms, we can write it like that also. V square minus U square is equal to 2AS. So this is the third equation of motion. So in this way, we have covered all three equations of motions with the help of graphical method. Hope you understood it. You go through the textbook as well, go through the diagrams, write on your own, try to draw the graphs, understand the parameters, understand the basic concept, understand that figure, what is the importance of that figure, what is meant by slope, what is meant by area, the replacement, rearrangements. Once you understand this logical sequence, it will be very easy to understand the equations of motions. So thank you.